get started.
非常高兴今天能够来到 Open Source Summit。
Very happy to attend Open Source Summit and to share our technology. First, I'd like to introduce myself. I'm Li Leding, coming from Baidu Cloud IoT. I'm also a member of LFH Technical Advisory Council. Today, I'd like to share with you OpenEdge, the general framework of edge computing. I'd like to introduce the background. So I think all of you are very familiar with edge. And you can see cloud and edge, and they're complementary. Cloud, they can solve the scale issue, and edge, they can solve other issues like latency and bandwidth consumption. And power connection limitation, and also privacy and policy requirements. To solve these issues, edge computing will be more suitable. And in this background, what kind of position would OpenEdge play? OpenEdge wants to create a central platform that can integrate both hardware and software. We can support like the AR computing devices, PC, server, and industry gateway controller, as well as MEC nodes and CDN and other services. OpenEdge hopes to drive the hardware to provide edge computing services. In terms of software, OpenEdge hopes to support different software ecosystem. Either it's smart city, intelligent, autonomous driving, etc. So OpenEdge wants to be the central platform that connects hardware and software and to provide the infrastructure. And the edge targets. Based on different scenarios, we have different kinds of edge computing. And OpenEdge aims to solve the following three problems. The first is on-premises microcluster. Secondly, we want to add AI chip onto this headless box. Thirdly, we can deploy a smaller cluster locally, and we can use, for example, 3 or 5 servers. Then I will talk about OpenEdge, the project itself. At the very beginning, Baidu developed this. We started development from the end of 2017, and then we decided to make it open sourced. And we have provided this website, openedge.tech, where there are bilingual training materials. You can scan the QR code to join the community. For the project itself, we will have a monthly agile development, and we have released 4 versions. In GitHub, we have more than 1,000 stars. It's one of the most popular projects on GitHub. And we want to focus on 3 major issues. First is to provide cloud-native computing capabilities on edge. We want to make sure this cloud-native infrastructure can smoothly operate on edge as well. Secondly, we want to have a large-scale deployment of unattended equipment. And this might involve millions of nodes nationwide. And you cannot have personnel to monitor and manage. Thirdly, we hope we can really help developers provide toolkits and services and to reduce the development cost and threshold. And in the long run, our vision is first to provide a standard edge operating system. Secondly, to provide a standardized edge toolchain for developers. And thirdly, we can make sure the collaboration among cloud, edge, and IoT. So our first target is to realize the cloud-native infrastructure on edge. Then you can see this is based on cloud-native as well. On the left, that's the core of OpenEdge. It's a software which can run independently on the core. Any common operating system can run on the software. The core will orchestrate all the services. And to solve the instability issue between cloud and edge end. And we can provide local storage on this step, even though there is no external network. In the middle, that's OpenEdge runtime. Normally we will use Docker, but for those who cannot support Docker, OpenEdge has provided static simulated container. And each module here represents a container service. Some are compulsory service or necessary services which can ensure the implementation. Like one can ensure the remote monitoring and management, and the hub can provide telecommunication network. And then you have the data volume. But we will have, for example, read-only version and editable version. And every time you don't need to download the whole application, you just need to take out the modules you need. That's the compulsory components, and then you have optional components. There will be an embedded optional package. It includes MQTT protocol server and connects it with OpenEdge. You can also upload this through client or upload it to other agent. And then in the middle, you will involve different kinds of calculation by using functions. You can leave all these technical problems to OpenEdge. That's the optional components targeting at IoT. On the right, by H5 interface, you can monitor and operate all the OpenEdge cases, and then send it distributed into the edge nodes. It's more suitable for small-scale edge management. It's easy to use, but for production scenario, We will use it to remotely control Kubernetes,
让 Kubernetes 的管理 API server
so that Kubernetes API server
二者打通，
can integrate with an OpenEdge server,
就部署所有的边缘节点。
and it can deploy along all the edge nodes.
在这个原生的架构上，我们希望能够支持各种各样不同的应用的执行。
And on this infrastructure, we hope we can support different kinds of
最左侧的
services, and then we have
直接跑在 OpenEdge
these modules.
OK 的，不需要做任何修改，只要把它放在 Docker 里面。这个时候
You don't need to do any changes, and then you just need to put it in the Docker.
靠它去更新你的
And then you can have OTA upgrade to iterate your version. And then you have the monitor.
负责数据的
A third part is the data input and output.
数据流量可以
For example, you have this port so that the external data can flow into your system.
程序和配置的分离，不重启而下发配置，这是最标准的 standalone
That's the standard
减少一些
standalone
可以在这个程序里面直接调
module.
SDK。
Or you can call back the OpenEdge SDK
让 SDK 帮助你实现协议处理。
to let the SDK realize the protocol, the metrics, and other
那如果你说
interface for you.
想要工程方面更简单一些，我们
If you want to have even simpler engineering,
函数计算，在这里只需要
you don't want to calculate the function, etc.
有 Python 有 Node， 然后
Then you can just use this function
C++的一种本地
code. It can support Python, C language,
然后
etc.
把所有的关于函数运行时这些工程上的问题交给 OpenEdge 来执行。
And you can leave all these functions to OpenEdge to run.
Lambda 完全兼容的，那基
And
本上
this also compatible with AWS
所有云厂，
Lambda.
百度在内，云上的函数计算。所以我们希望的理念呢是说，大家在云上去开发函数，然后一键
So we hope you can develop your function on the cloud, and then you can deploy it onto the end.
应用你的业务需要由多个
On the right,
服务互相协作而成。比如说，你先进行视频采集，
if you need multiple services collaboration, for example, you need video, and then you need data processing on the backend, then you can have service mesh. We have MQTT to link all the different apps. In the future, we might provide Istio to link all those applications.
各种你所喜欢的 APP 的模型去开发一个边缘的应用。当然，在所有
But
这种模型里面，我们
among all these models,
使用函数的方
we
式
still recommend function.
内置了函数计算单位。
There are embedded functions in OpenEdge as well. You can see the function architecture. On the left, it can take two kinds of protocol like
同时呢，它也可以
FTP,
调用我们现在支持的是 gRPC 的协议。然后
and we also support gRPC protocol.
service 它 fast 的运行时
And
会托管所有的工程问题，
Also
我们
fast,
会直接实现了一个
which can take care of the engineering
本地
problems,
设备上的一个弹性的函数实例，随着
can give you flexible functions on the local
数量会
server.
增加，然后我们的附带均衡器会 round robin 的
And the
方式
load balancer
然后随着流量的下降，
deploy the resources, and when the traffic goes low, it will reduce the cases of functions and then allocate the resources to other tasks.
大量的数据的共享，比如说用户的
Behind it, we will share the data on the back
然后
end.
程序的配置会共享一个数据体，
For example, all the configurations, they will share a data set.
它还可以
Two different functions
数据源，这样
can share a data volume,
靠磁盘进行
and then
交互，
two data can share
像未来
with each other by disk.
计算的模式，
That will be the mode we will promote in the future.
上的函数计算保持始终保持一致。
And that's consistent with the computing on the cloud.
本地的计算能力呢，重要一点
With this local computing capability, you also need to have this remote management capability.
所有的边缘节点。
By a simple method, you can manage all your nodes,
但是今天呢，直接说远程管理，其实这个事儿呢不是很新鲜。
but also remote management is not new today. Many products have this capability. The difference of OpenEdge is that we have different versions.
所以每一步的操作都会形成一个记录，
Each step will be recorded,
版本。那
and correspondingly, there will be a version
所以一旦
created.
操作失误、错误，或者是某一个
For example, if there is an error or if there is some improper practices,
版本，然后每一个
you can refer to the previous versions. And for each version, after OTA, you can download all of it.
This is called a declarative method, and everything will be packed together and will store together. Then through the practical, it will be sent through HDBS style and then downloaded into the local storage. And now we have the differentiation of what should be reloaded and what should not, so as to reduce the end load and increase efficiency. There are 4 aspects for configuration. To configure the data stream relationship, from where to get the data and from where we process the data. And there can be a function or other writings. And to configure these documents without having to pause the reloading. So these are the remote control from OpenEdge. So for our edge scenarios, our OpenEdge can optimize these scenarios. So these can be run on a small device or bigger device as you wish. To load it on a multi-CPU server, OpenEdge can self-adapt itself. It can support Linux, Mac OS, Windows, but it only relies on the core, so there is no version limitation. So it supports on different types of chips, such as x86. We're trying to make OpenEdge to support more versions. And also OpenEdge supports for unstable network. So when under certain circumstances, the network can be very little or even lost connection. If you want to synchronize your data on the cloud, then OpenEdge provides a local data storage. So when the network gets stable or reconnected, the data can be resent to the cloud. So if the network is always off, OpenEdge will store all the data and it will do regular clearing. And also the third feature is that OpenEdge can provide automation. It's highly automation. So at the very initial stage, it has realized automated running. We want complete automation, so we design it in this way. Once connected to power, it will start itself. It will send a code to a remote server and sending a license to back to prove OpenEdge's ID and to make sure that all the operations are encrypted. So where did this code come from? Partially from Baidu's partner. When they manufacture this device, they will provide a code along with it. The other is that from calculating from the IP address and other information that we get the new code. So with the design of OpenEdge, in this way, we don't need remote SSH, we only need an OTA. And the last optimization is the I/O limited. So on a typical industrial controller, we might use a card, the SD card as a buffer need to contain the data. So OpenEdge use a lot of storage and sequence method. So even on a weak device, we can provide very good operation. For example, sometimes there can be a traffic of 40,000. So what do we want it to be in the future? We want to do this in our way, in our meeting our expectations, because everything is down to the edge. You don't have to connect to this operation system and to configure all the services. The edges can solve all the problems. There is no need to use user-end library. So with these premises, we can create a brand new operating system. This OpenEdge Linux OS, we have borrowed the Linux infrastructure. So it's comprised of a repository, and it cannot be written. So it includes a POSIX layer and BusyBox for emergency repair, and also the container runtime. And we are choosing between runC and also a core server running in a layer that cannot be written. So everything that can be written, including all the data generated and certificate, will be stored in a separate disk and can be fixed. So operation and data storage are separated, and there's no need to repair or install on the local edge. And the local disk will keep it to itself. So that's what we expected to provide. With this operational system, we will keep it down to 26 MB. And we will make it even smaller. It will be installed and running within 1 second. So OpenEdge, next step will move to the developer tools. This is the developer's kit expectation. Right now we have provided message SDK, locking the different protocols on the bottom layer. And also we will add different kits. We will provide C and C++, Portal, and also Golang Portal. So there's no need to download an ARM GCC. This is what we want to do at the phase 1. Next step, on this foundation, we will develop a deployment kit. With this kit, so the edge applications can be deployed on the manufacturing devices and also can be adapted. Also, the CI/CD and DevOps on the cloud can be developed and repaired all in one package. So, the OpenEdge framework and SDK and the kits will be integrated together to provide an OpenEdge graphic ID. With this framework, we look for the applications. So we want to provide an infrastructure that is not directly related to a service, to business. So we will add solutions for different scenarios. I will give you an introduction to what Baidu have done. It is called Baidu IntelliEdge. The relation between IntelliEdge and OpenEdge is that IntelliEdge and OpenEdge it's for developers. It involves remote management built-in service, while IntelliEdge is for commercial use, for enterprise. We'll focus on the Edge AI and also the real-time data management. Sorry, the connection is weak. So except for these two solutions, we will also provide more complex services for specific needs of the companies. So we have given this concept, that is the fusion of edge and cloud. So there is an interaction of edge side and cloud side. So on the local side, we can do computing and AI. And the data, the results will be sent to devices as requests. And the locally collected data, with the approval of the end user, will be uploaded to cloud safely. So the Baidu IoT platform will collect these data and store the data in a database and do further processing, or maybe further pass these data to Baidu AI training platform. So with this model, and through OTA, this data can be sent back to the edge, and the edge side will be enhanced with a more powerful tool, so forming a cycle. So AI solutions involve different kinds of services, which are down to 3 categories. The first one is video ingress service. So the online cameras can gather these videos, and when these videos are collected, they are processed on the platform And the second solution is the ML interface as a service.
So no matter it's Baidu's Title or other accelerators, whether it's X6 CPU or CUDA's GPU or Intel's Mobitus or other new chips, OpenEdge can ensure that we could have artificial intelligence analysis of this locally, and then we can have this processing on the back end. And on the back end, you can just write a function to do this. And for this post-processing, you can upload your data onto the cloud. And you can also have some judgment about the structured data, and then have some local management and deletion. To write a script or a function to delete those unnecessary or not useful data. And here we're developing data solution. The first is data protocol service, which can support, for example, NetBus and other protocols. And in the middle, we will provide a streaming computing solution, which is even more powerful. You can have multiple data input and output, and also this streaming computing does not require you to have programmed CPI. After you process the data, you can send this to anywhere it needs, and to, for example, monitor the device, control the device, and then you can have the notification and warning. Nowadays, almost all the cloud products provide warning and monitoring function. For the long run, Baidu hopes to build a holistic solution. We hope this could be run on IoT devices, either public cloud, private cloud, and this can transcend across different scenarios and can be exchanged freely. You can use the standard computing methods on the cloud native, and also we support the whole community. And we will provide toolkits for the developers. And to find more hardware providers to make sure that we can have more devices that are suitable for edge computing. Last, I'd like to introduce our current applications. For example, we work with Baidu, other teams. We have this camera, and this camera can be embedded on the OpenEdge device, and then we can monitor whether there is any defect in real time. And also we can have the samples and to train better models. If we work with power plant, and we can have this OpenEdge device embedded in the electricity meter, so that they can know how much electricity or power they have used, and then we can keep a good balance among the peak time. And also we can have the edge computing device embedded on these trucks, and the trucks that contain and transport some raw materials, and we can know whether there are raw materials falling off the trucks. And also we can have this edge computing device embedded on the charging pile, so that it can better predict the charging efficiency. And also we have cooperation with drones. We have OpenEdge devices embedded in drones, the drones do not need to upload the data to the cloud. We can have real-time analysis. So with edge computing, previously you need interference or help of cloud, but now you can do this locally on the agent. So that's all I want to share with you today. If you're very interested in OpenEdge project, you can scan the QR code to join our community. Thank you. Any questions? Yes. Apart from remote management, all others, they are open source. And we're going to enter the new Edge project, become a member of Linux Foundation.